Okay, today's lesson covers section 5.5 out of our textbook, and we are talking about theorems about roots of polynomial equations. Um, we're continuing our study of solving polynomial equations, and sometimes guessing or plugging and checking is not always an efficient method to solve polynomial equations, so we have theorems to help us minimize the number of guesses. Okay, and probably the most important theorem that we have is something called the rational root theorem. So you have a big long polynomial, might look something like this, or down here you'll see this is 1. Okay, there are a limited number of possible roots that you have to think of. Okay, if you have any integer roots, remember what integers are. Those are basically no fractions, no decimals. Okay, if you have any integer roots, they have to be a factor of a sub 0, which is your constant term. Okay, and if they are rational roots, hence the name rational root, and remember that's where we have our fraction. All right, rational roots. Remember that's like a over b. Those are our fractions. Rational roots will always be what they call p over q, where p is an integer factor of the constant and q is an integer factor of the leading coefficient. Yeah, a bunch of math speak. This is what I remember. Okay? You're going to take, this is your constant term, but remember this visual that you're taking this and putting it over that. I don't really like that one to go far enough. Taking this and put it over the factors of that one. The factors of this are your p. The factors of this are your q. So here is an example. We have 21x squared plus 29x plus 10, okay? So they're taking the factors of this term and they're going to put it over the factors of that one. Factors of 10, plus or minus 1, 2, 5, and 10. The factors of 21, 1, 3, 7, and 21. And so we're going to talk about how to get all the combinations of putting this over that to get your possible rational roots. Okay? Now, once you have found that root, you're going to use what we just talked about in the last lesson, synthetic division, to factor the polynomial. And we're going to continue that until we have a second degree polynomial, also known as a quadratic. And then you can, I'm going to say this because that's probably what most of y'all want to use, okay? But we've talked about several ways of solving a quadratic, but you can use the quadratic formula to find the remaining roots. You can also, of course, factor, and if you can factor and know how to, that's going to be much faster, or you can complete the square. Um, those are most likely going to be the ones that we would see most often. Okay, most likely, most often, double speak. All right, so what are the rational roots of the equation? All they did was ask for the rational roots. Oh, we have to actually go find the rational roots. They didn't ask us to list. Sometimes they just ask you to list them. Okay, so when you do this problem, we got to find the rational roots. So I'm thinking of, oh, let's go with the factors of this number over the factors of that number. Okay, that's my little visual that I use to remember this. That's my P over my Q. So I'm going to come over here. This is always step 1 when you're doing a problem, is to find those rational roots. So I put my plus or minus first and just know that whatever I find is possible. Can be plus or negative. On the top, I need the factors of 8. 1, 2, 4, and 8. And on the bottom, I need the factors of 3, 1, and 3. Okay? Now, this leads me to, I got to think about all the possible combinations. So I got to put all of these numbers over 1 and then all of those numbers over 3. So when you put them over 1, okay, that means that I'm going to have, of course, 1, 2, 4, and 8. But when I put them over 3, then I'm going to have 1 over 3, 2 over 3, 4 over 3, and 8 over 3. So those are the possible, this right here, these are the possible rational roots. Possible rat roots, you probably like that. Okay, so from here, I need to go figure out which ones are actually going to be my rational roots, okay? So right now, what you want to do is let's go. Step two is basically we're going to make a t-chart. Okay, there are several ways to do it. There's some another theorem we're going to learn later on. But that t-chart, what I want you to find first and foremost, and whether you write it horizontal or vertical doesn't matter. I'm going to go ahead and do it vertically. Okay, um, and you're putting in for x and you're getting a number that comes out. Okay, so we think of it as y. And the numbers that I want you to try are -1, 0, and 1. Now, first off, if you put in 0, y'all, what do you get? 0, 0, 0. We get -8. That's an easy one. Okay? If you put in 1, that means add up those coefficients. So that's 3 plus 7, which is 10. 10 plus 6 is 16. And 16 minus 8 is 8. And now to go find -1, if I plug in -1, I'll tell you something. I'm going to tell you, and if you don't remember, do you know how to go plug it in? Okay? I actually just have to change the odd exponent. So that's going to make this -3 plus 7 minus 6 minus 8. So that's 4 minus 6 is -2 minus 8 is -10. Okay? Now, the reason I want you to do those numbers is because we've talked about this before, that we look at these numbers, and when they go from positive to negative, this right here goes from positive to negative, then I know that I have a sign change. And that means there has to be a root. All right, this is a sign change. One's positive, one's negative. So that means there has to be a root in between here. So I'm going to go look at my list, okay? And what number in here is in between 0 and 1? And it's either 1/3 or it's 2/3. So we're going to go try that. Um, let's go start with this right here. So I'm going to do 1/3. Not necessarily fun to do fractions, but it's the easiest way to do it. All right, and remember our synthetic division, so I write the coefficients 3, 7, 3, 2, 1, 0. So we're good. 3, 7, 6, -8. And then I'm going to write, I don't write anything, and then I have this. And if it's a factor, I hope y'all are telling yourself and remembering, what does that have to be? It will be a 0. So I come down, always bring that number down first. 3 times 1/3 is 1. So I'm going to write a 1 here. And then 7 plus 1 is 8. 8 times 1/3 is 8/3. And 6 is 18/3. So 18/3 plus 8/3 is 26/3. Now, this is 26 over 9, and you don't really have to find it. All you need to know is it's not going to be 0. So you can stop, okay? You don't need to spin your wheels doing something that's not going to work. But let's go try 2/3. So I have 3, 7, 6, -8. And then I come over here, and again, I'm hoping to get 0. Bring down my 3. 2/3 times 3 is 2. 7 plus 2 is 9. 2/3 times 9 is 6. 6 plus 6 is 12. And 2/3 times 12 is, woohoo, -8 plus 8 is 0. So that means that this is one of my rational roots. Okay, so what are the rational roots? X equals 2/3. This is a quadratic, but the other numbers you can actually try from here. Let's see. Oh, hold on one second. Okay, so remember, we keep going. We might have some more rational roots. This, remember we talked about before, gives us 3x squared plus 9x plus 12 equal to 0. I see a common factor of 3, so I'm going to divide everything by 3. Excuse me. So that gives me x squared plus 3x plus 4. Now, if that factors, then I have the factors of 4 that add to give me 3. And there are no factors of 4 that add to give me 3, so it doesn't factor, which means there are not going to be any rational roots. The other roots that we have are going to be irrational. And they're only asking us in this problem for the rational roots. basically those that are in that list. And they're not in that list. So we're good. All right, look at the next one. Oh, I need a little more room. Okay, so what are the rational roots? And some more room. What are the rational roots of 2x cubed plus x squared minus 7x minus 6? So what am I going to do first? I'm going to do my p over my q to find the possible rational roots. So that's plus or minus the factors of 6, 1, 2, 3, and 6, over the factors of 2. And then I have to go give the combination. So of course we always start out with the top. Those are our integers. And then I have 1 over 2. 2 over 2, well that's the same thing as 1, so I don't need to list it again. 3 over 2. And 6 over 2 is the same thing as 3. So those are all my possible, again, possible rational roots. Okay? And now, for the next step, okay, we make our table. And I want you to make your table of -1, 0, and 1 for x and y. And 0, remember where's 0? 0 plus 0 minus 6. Okay? Put in 1, and I told you to add up these numbers. So that's 2 plus 1, add up the coefficients. 2 plus 1 is 3, minus 7 is -4, minus 6 is -10. So there's not a root in between these two. Okay? And then I said change the signs of the odd powers. So that's -2 plus 1 plus 7 minus 6. So -2 plus 1 is -1, plus 7 is 6, minus 6. Ooh, there's a root. Coolio. So this right here, because it was equal to 0, that means that is one of my roots. All right, it's in my list right there. Okay, so that's the number I'm going to start with. And I'm going to go, oh, lost my little guy. I'm going to go use -1. And my factors are 2x cubed, 1x squared, minus 7x, minus 6. And I know it's a root. And I know we just talked about this before with our remainder theorem. Okay, this has got to be 0. So this has got to be 6. And I'm just telling you that so that when you do this, you will get the right answer if you get 6 here. So I bring down my 2. -1 times 2 is -2. And 1 plus -2 is -1. -1 times -1 is 1. -7 plus 1 is -6. And -1 times -6 is 6. So we got that. All right. So remember, this is the third degree. So this one right here is a second degree. Okay. And this brings me to my second degree polynomial, which is going to be 2x squared minus x minus 6. And I'm going to see if that can factor. Are there any factors of 12 that subtract to give me 1? Okay, so I'm looking for the factors of 12. I don't like the way that looks. Okay, the factors of 12, or is it -12? Well, and so if you want to write -12, either way, it lets you know you got to subtract the numbers. They have to have a difference of 1. So hopefully you know that's 3 and 4. And I need -1, so I want that 4 to be negative. So I talked to y'all recently about how to do this with the ratio. And so A is equal to 2. So I'm going to write 2 to 3 and 2 to -4. And this one simplifies 1 to -2. So these are my two ways to factor. So that gives me 2x plus 3, 1x, you don't have to write the 1, minus 2 equals 0. Can't see that minus very well. Okay, and then we set each factor equal to 0. X minus 2 equals 0. So that means x equals 2. And this one, 2x equals -3, so x equals -3 halves. So that gives my final answer. What are the rational roots? I'm going to write them up here. X equals, we had -1 to start with, and then we found -3 halves and +2, and those are in that list. Okay? Now something else that helps us remember our roots, or find our roots of polynomials, okay, and especially going backwards when we have to, is something called the conjugate root theorem. And y'all are so wonderful because you know what conjugates are now. You remember, those are those factors that we have seen thus far that are a plus b and a minus b, because when we multiply those, you know what we get. Okay, but they look exactly the same except for the sign of the second term is different. Okay, and so what this is telling us is if we have an irrational root or we have a complex root, they always come in pairs because they're basically coming from the quadratic formula where you have plus or minus. So if I know that 1 plus 3i is a root, then I know that 1 minus 3i is also a root. So they're just asking us to write the conjugate of the root. Okay? If I have 4 minus the square root of 7, then I know I'm going to have 4 plus the square root of 7. If I have negative 2 minus 9i, you only change the second one, then I'll have negative 2 plus 9i. And if I have 15 plus the square root of 10, I'm going to have 15 minus the square root of 10. So we just wrote the conjugate, but you just know every time you have one of these roots, whether it deals with an I or a radical, you will have both of them as roots of your polynomial. So your question might be, a cubic polynomial, p of x, has real coefficients. That's just necessary. If 3 minus 2i and 5 halves are two of the roots, what is one additional root? Well, if I have 3 minus 2i, then what else do I have to have? I have to have 3 plus 2i. And so that's all it is. This one is not, it doesn't have a radical in it, and it doesn't have an I in it. So that one has no bearing on the problem. Okay, but the fact that they told you this was in there meant that's also a root. Okay, so we need that because sometimes we have to go backwards. We're given the roots of a polynomial, and we did this before. Okay, just a little bit fancier because this time we have a quartic. And so what is a quartic? I hope you're saying to yourself, that's a fourth degree. So I'm going to end up with x to the fourth. Okay? So what is a quartic polynomial with equation that has roots of 2 minus 3i, 8, and 2? So how many roots did they give me? 1, 2, 3. But if it's quartic, or if I have 2 minus 3i, then I also have to have 2 plus 3i. Okay? So we're going to do what we did before, okay? And the first thing, we're just working backwards with that process we were doing of solving things and our zero product property. So what I'm going to write, p of x, oh, actually, let me go back. Let's go back to this because this is what we've said. This tells us we have x equals 2, x equals 8, x equals 2 minus 3i, and x equals 2 plus 3i. This is what we've done before, okay? And then we had to get the factors from that. So we set all those equal to 0. So that meant this factor, this is x minus 2 equals 0. This is x minus 8 equals 0. This is x minus 2 plus 3i. That's the factor. And this is x minus 2 minus 3i. So notice how those changed when we get. So remember, like I said, we've done this before, so you know that these are the factors of our polynomial. See how they all have an x in them. So watch what's going to happen here. So this means that p of x equals x minus 2, x minus 8, x minus 2 plus 3i, and x minus 2 minus 3i. Okay, that's my polynomial. I need to multiply it out. I got to get rid of those i's. Okay, so you FOIL this part. So basically all we're going to do, let's write it like this. I'm going to do this part, and then I'll take care of the other part. So let's do this one first, and it's going to look like this. All right, if I FOIL, and it's still all multiplying. So this, when I FOIL it, I got to keep it in parentheses. So we got x times x, which is x squared. I have my outside, which is minus 8x. My inside is minus 2x, and my last is plus 16. Okay? Now, this one's a little tricky. Gotta pay attention. Okay? Hopefully, you notice on this, and I'm going to highlight it so you can see I'm using green, so let's see if blue will show up. Notice that this part right here, I don't like the way that turned. Let's go like this. This right here, those are the exact same thing. That says x minus 2, and that says x minus 2. And this one says 3i and 3i. But really what I want to know if you can tell that this is like a plus b. I'm going to write it on top here. A, let me use a different color so that shows up a little bit better. Let's go with, red. A plus b and a minus b. Okay, y'all, this is a shortcut to multiplying these out. And I did about 5 or more of these problems before I realized it was so long to multiply it out, and if I recognize that pattern, it wouldn't take me as much, okay? So it will always come out like this. So if you can get it down, your life will be easier, okay? Surely y'all can tell me a plus b times a minus b, a plus b times a minus b is equal to a squared minus b squared, okay? We could even go a step further if you want to, because I won't do that because sometimes it won't always be I. Okay? So that means when I write this, I'm going to have a squared, which is x minus 2 squared, minus 3i squared. Okay? That was my a, remember? So that's this part. So on my highlighter, okay, this is my a that got squared, and that's my b that got squared. Okay? So continuing, we'll simplify this guy. X squared minus 10x plus 16. And then on this, okay, I got to simplify this thing. So x minus 2 squared, that's going to kind of doing that PST thing backwards, is going to be x squared minus 4x plus 4. Okay, that's squaring that thing. We've done it a lot. If you need some help, come see me. All right, and then when I square that, it's going to become minus 9i squared. Okay, and we've talked about a lot. What does that really mean? Well, that means that this is going to be plus 9. Okay, because the I squared changes that. All right, so as we simplify that, let's go with x squared minus 10x plus 16. And this one's going to be x squared minus 4x plus 13. Okay, and we're going to pause for 1 second. Sorry, get interruptions. Okay, so we're going to let you stop at this point. Oops, p of x. Really what I want to make sure that you've simplified any terms, okay, that you have multiplied out, okay? Um, so I've got x squared minus 10x minus 16, but make sure you don't leave any kind of I in your answer, and we'll just leave it at that, okay? So the last thing I want to tell you about is something called Descartes' rule of signs. And you can read this. I want you to read that to yourself, okay? Because I can read it to you, but that's not the point of the video. The point of the video is for me to help simplify that. So pause if you want to read it, and then start it back up again after you read it, and then I'm going to tell you what you do with it. Okay? So we're back. What does Descartes' rule of signs tell you about the real roots? Okay? So what this is telling us, okay, or what you're supposed to do, we're either looking for, or we're trying to determine how many positive real roots we have and how many negative real roots we have. Not complex numbers, but real roots. Okay, so what you do is you look at this problem and you look at the sign changes. Okay, this is for the positive ones. Okay, you look at what you have. This is positive, this is negative, this is positive, and that's negative. I'm just looking at the coefficients, okay? Is this a sign change? From positive to negative, that's a sign change, so that's 1. And then if I go from negative to positive, that's a sign change, so that's 2. And then from positive to negative is another one. So I have 3 sign changes, okay? And when I'm talking about sign, I'm going from positive to negative, okay? Now, that means that I have, well, let's write this first. Because I have 3 of them, I will have 3 or 1 positive real root. Okay? Because whatever number you get, it goes down by an even number, whether it's an odd number or an even number that you start with. Okay? So let's go look at the negatives. Now, if it's a negative one, okay, you change the sign of your odd exponents. So I'll write that. Change sign of, that does not look like change. Sorry, let me fix that. Change sign with odd exponents. Okay, so that's an even exponent. I don't change that sign. This is an odd exponent, so my negative is going to be positive. This is an even, so it does not change, and this doesn't have one, so it stays the same. Okay, do I have a sign change? Nope. Do I have a sign change? Nope. Do I have a sign change? Yep. So that means I'm going to have one negative real root. Now, it's an easy thing to do, and sometimes you can start off a problem like that. It just helps your guessing, okay? It's a lot to take in, so right now I just want to make sure you know how to use it. And that is all we have in 5.5, so if you have any questions, please come ask me. I'll be happy to help you. Or write them down and email me. Thank you.